The universe is vast, an endless expanse of cosmic wonders stretching out in every direction. It's a realm of unimaginable scale, filled with mysteries that have captivated humanity for millennia, filled with wonders that challenge our imagination. From swirling nebulae painted across the cosmos to distant galaxies billions of light years away, the universe constantly presents us with phenomena that push the boundaries of our understanding. We live on a tiny, fragile world, a pale blue sphere teeming with life, suspended in the vast emptiness of space, a pale blue dot in the cosmic ocean, a single point of light, almost insignificant in the grand scheme of things. Yet it is home to everything we know and love. For centuries, people have looked up at the stars, their eyes drawn to the celestial tapestry above, and wondered about our place among them. They sought answers to fundamental questions about our existence, our origins, and our destiny. The ground beneath our feet seems flat, a seemingly endless plain stretching out before us, stretching to a distant horizon. This perception, this simple observation, has led some to believe that our world is not the sphere we know it to be. This simple observation sparked the flat Earth theory, a concept that challenges the very foundation of modern science. The idea that our world is a flat stationary disk, a concept that defies centuries of scientific discovery and observation, surrounded by a wall of ice, Antarctica. According to this theory, this icy barrier prevents us from falling off the edge of the world. In this model, the sun and moon circle above, like celestial dancers performing an eternal ballet, acting as spotlights and creating day and night. These celestial bodies illuminate different sections of the flat Earth, giving us the illusion of a rotating planet. But why does this idea persist today, in an age of satellite space travel and readily available scientific information? When we have photos of Earth from space, images that clearly show our planet as a sphere, and centuries of scientific evidence, what is it about this theory that continues to captivate and intrigue so many people? Despite overwhelming proof of a spherical Earth, a concept supported by countless experiments and observations, the Flat Earth movement thrives online, finding fertile ground in the digital landscape of the Internet. Fueled by skepticism and a desire to question authority, it's a movement that challenges the established order and offers an alternative narrative to the world around us. Our journey isn't just about debunking a myth, it's about something far more profound. It's about understanding why it endures. Why, in the face of overwhelming evidence, do some people cling to this belief? We'll explore its origins, tracing the roots of this idea back through history, why it resonates today, examining the social and psychological factors that contribute to its appeal, and examine the evidence ourselves. We'll put the flat Earth theory to the test, using the scientific method to analyze its claims. This is a story of curiosity, science, and our search for truth. It's a journey to the edge of belief, where we'll confront our assumptions and challenge our understanding of the world. Let's look at how simple observations, the kind we make every day, can lead to profound conclusions. How can we trust our senses, and how can we use reason and evidence to arrive at a deeper understanding of reality? Let's begin. Let's embark on this journey together and see where it leads us. The flat Earth idea, a concept that seems almost absurd to us now, was once the default understanding of our world. It's a perspective deeply rooted in human history, predating scientific instruments and modern understanding of the cosmos. This notion of a flat Earth was prevalent for ancient civilizations. It wasn't a matter of ignorance, but rather a reflection of their immediate sensory experiences and the limitations of their observational tools. Before the advent of telescopes, satellites, and sophisticated scientific methodologies, people naturally trusted their senses. The ground beneath their feet felt undeniably flat, stretching out to the horizon, and the sky appeared as a vast dome arching above. This direct perception shaped their worldview. Mesopotamians, for instance, imagined the world as a flat disk, a solid landmass surrounded and floating in an endless ocean. This watery expanse was believed to extend infinitely, a boundary beyond which no one could venture. In ancient Egypt, the earth was also conceived as a flat expanse, with the sky represented as a goddess, often not, arching protectively overhead, her body forming the celestial vault. These models, while seemingly simplistic to modern eyes, perfectly fit their daily experience, and more importantly, help them predict crucial events like seasonal changes and the annual flooding of rivers, vital for their agricultural cycles. Early religious texts, like those from the Hebrews, similarly described a flat, circular Earth, often depicted as resting beneath a solid firmament, a dome-like structure that separated the waters above from the waters below. But the intellectual curiosity of the Greeks changed everything, ushering in a new era of understanding. Philosophers like Pythagoras and Aristotle challenged the prevailing flat Earth view and proposed a spherical Earth, a revolutionary idea supported by careful observations and logical reasoning. They noted that as travelers moved south, new southern stars would rise above the horizon, a phenomenon impossible on a flat Earth. Furthermore, they observed the Earth's round shadow cast upon the Moon during lunar eclipses, providing compelling visual evidence. Then Eratosthenes, in 240 BC, took this understanding a step further. He ingeniously measured Earth's circumference with remarkable accuracy using the angles of shadows cast in two different cities. A true triumph of reason, geometry, and early scientific inquiry. This groundbreaking knowledge wasn't lost to the ages. It was meticulously preserved, translated, and expanded upon by scholars across various cultures and throughout history. The acceptance of a round Earth became the bedrock for future exploration, enabling more accurate navigation and map-making. These ancient observations, when combined with critical thinking and a thirst for knowledge, ultimately led to a far deeper and more accurate understanding of our world and its place in the cosmos. The historical journey from the flat Earth paradigm to the round Earth model stands as a powerful testament to the enduring nature of human curiosity and the remarkable progress that can be achieved through scientific advancement and intellectual evolution. If we've known the Earth is round for millennia, why does the flat Earth idea persist? The internet and social media create echo chambers where unconventional ideas spread rapidly, unchecked. Distrust of authority, governments, scientists, media, fuels conspiracy thinking. For some, believing in a flat Earth is an act of rebellion, a way to feel special, or in the know. The flat Earth community offers belonging and identity, making it hard to question the belief without losing social ties. The model's simplicity is appealing, the world feels flat, and the complex reality of a spinning globe can seem abstract. Personal experience often outweighs scientific explanation for many. The flat Earth idea offers comfort and a sense of central importance. Ultimately, it's less about evidence and more about psychology, community, and distrust. Understanding this helps us see why the idea endures. Let's move from belief to evidence. The scientific model shows Earth as an oblate spheroid slightly bulged at the equator, flattened at the poles. Earth's rotation gives us day and night. Its orbit around the Sun creates seasons. This model explains time zones, the Coriolis effect, and global weather patterns. Gravity shapes planets and stars into spheres. A flat disk would be unstable. Flat Earth models often replace gravity with upward acceleration, but this idea falls apart under scrutiny. What force could push the Earth upward forever? Why don't we see relativistic effects? The spherical model is consistent, predictive, and explains countless phenomena elegantly. It's not just a theory, it's a framework built on centuries of observation and measurement. The evidence for a round Earth is overwhelming and interconnected. Science gives us a coherent picture of our place in the cosmos. You don't need a rocket or even a plane ticket to see evidence of Earth's curve. While images from space provide undeniable proof, the reality is that you can observe it with your own eyes, right here on the ground. Just visit the beach. The seemingly simple act of looking out to sea can reveal a fundamental truth about our planet. Watch a ship sail away into the distance. Observe carefully what happens as it moves further and further from the shore. Instead of simply getting smaller, it disappears hull first, gradually sinking below the horizon, then the mast eventually follows. This wouldn't happen on a flat plane. This phenomenon proves the surface is curved and that the ship is sailing over that curve. From a higher vantage point, like a cliff or a tall building, you see farther over the horizon. The increased altitude allows you to see beyond the curve that obstructs the view from ground level. This extended visibility is another sign of curvature, a subtle but powerful indication of Earth's spherical shape. At sunset, climb a tall building, and you might witness a fascinating phenomenon. You'll see the sunset once at ground level, and then by ascending to a higher altitude, you'll see the sunset a second time. This happens because you can see farther around the curve from an elevated position, briefly extending your view of the setting sun. On a flat Earth, the sun wouldn't disappear below a horizon. It would simply shrink in size and fade into the distance, remaining visible, albeit smaller, until it was too faint to see. Instead, it dips completely below the horizon, obscured by the curvature of the Earth. The stars, those distant beacons of light, offer even more proof of our planet's shape. As you travel north or south across the globe, the constellations visible in the night sky change dramatically. Polaris, the North Star, a constant companion in the northern hemisphere, gradually vanishes below the horizon as you venture into the southern hemisphere. It's replaced by entirely new constellations, unseen from northern latitudes, a celestial tapestry unique to the southern skies. If Earth were flat, everyone, regardless of their location, would observe the same stars in the same patterns, a single, unchanging view of the cosmos. These simple, everyday observations, accessible to anyone with a curious mind, reveal the truth about the shape of our world. The evidence is all around us, woven into the fabric of our daily lives, waiting to be noticed and understood. Our ancestors, without the benefit of modern technology, used these very clues to deduce Earth's shape and size. They did this long before the advent of space travel and satellite imagery. The world's curvature is visible in ships disappearing hull first over the horizon. It's visible in sunsets that vanish below the horizon. And it's visible in the changing patterns of the stars as you move across the Earth. You can see the proof for yourself, simply by observing the world around you with an open mind. The round Earth is not just a scientific theory presented in textbooks or seen in pictures from space. It's a tangible, observable experience, accessible to anyone willing to look. The ultimate proof came when we left Earth and looked back. Since the 1940s, photos and live video from space have shown our planet as a rotating sphere. These images come from multiple countries and agencies over decades. Claims of a global conspiracy to fake them are implausible, requiring silence from thousands across rival nations. Live streams from the International Space Station show Earth's rotation, weather, and day-night cycles in real time. GPS and satellite networks rely on spherical geometry. They wouldn't work on a flat Earth. Every planet we've visited is a sphere. Why would Earth be the lone exception? The view from space confirms what we already knew: our world is round. Eclipses offer spectacular direct evidence of Earth's shape. During a lunar eclipse, Earth's shadow on the moon is always curved. Only a sphere casts a round shadow from any angle. Aristotle noted this over 2,000 years ago. Solar eclipses, too, fit the spherical model. The moon's shadow traces a narrow path across Earth, predictable by orbital mechanics. Flat Earth explanations require ad hoc, invisible objects, far less convincing. The scientific model explains eclipses simply and accurately, without extra inventions. Eclipses are nature's demonstration of our planet's true form. The shadow play in the sky is a beautiful confirmation of our cosmic reality. The evidence is written in the heavens. The persistence of flat Earth belief is rooted in distrust, not ignorance. Many feel let down by institutions, governments, corporations, even science itself. Scandals and conflicting advice erode trust, making conspiracy theories appealing. Science can seem inaccessible, filled with jargon and math. Flat Earth arguments are simple, based on common sense and direct observation. Confirmation bias reinforces these beliefs, especially in online communities. Breaking free requires more than facts. It means rebuilding trust and critical thinking. The challenge is as much social as it is scientific. Our journey spans ancient myths to modern science, from ground to space. The flat Earth idea was a logical start, but curiosity and reason led us to the truth. Evidence surrounds us: ships, shadows, stars, and photos from space. The round Earth model is robust, precise, and essential for exploration. Flat Earth belief today reflects social dynamics, not scientific reality. It reminds us to communicate science clearly and foster trust. The image of our round Earth inspires humility, wonder, and shared responsibility. Embracing this truth is about understanding our place in the universe.